Hello everyone, welcome to my channel PeachyCloudSecurity. I am Anjali Shukla, Senior Security Engineer and speaker and trainer at various international conferences. I'm a founder of Kubernetes Village and leading OWASP EKS Code project. This is two-part session where in the first part, I will discuss the EKS basics, architectures, and how EKS is different from Kubernetes, and authentication and authorization. Whereas in the second part, I will discuss the top 10 best practices for the EKS. So let's start with our first session and let me share my screen. So today we will discuss AWS EKS basics, and let's start with understanding of what is Amazon EKS. So AWS Elastic Kubernetes Service is a fully managed service that simplifies management, deployment, auto scaling in our environment. And developers do not have to worry about the complexity of the underlying infrastructure. They can just focus on their application code. Next is Kubernetes component. So components are pretty much similar in Kubernetes as well as in EKS. We have control plane and a worker node. On a traditional Kubernetes environment, we have to manage everything like control plane and worker node as well. Whereas if it's an AWS EKS, control plane is managed by the cloud provider, that is AWS in our case, and we have to manage the worker node. If we are using the Fargate service of AWS for the worker node, then this worker node are also managed by the AWS. So in control plane, we have components like API server, etcd, scheduler, Kube Controller Manager, Cloud Controller Manager. This Cloud Controller Manager, this component is only present when the Kubernetes is managed by a cloud provider. This is to communicate with the cloud provider APIs. In worker node, we have kubelet, kube proxy, and a container runtime. Let's understand the architecture and see how these components work together. So on a control plane, I have API server, which is the brain of the cluster. And every request, authentication, authorization is accepted by the API server, first of all, from the control plane. So when a pod creation request, for example, comes to the API server, it authenticate and authorize that request and check that whether the user is authenticated and authorizing to create a pod. Then it stores that specification in the etcd. Etcd is a key value based database which stores every piece of information or all the object information that are running within the cluster in it. Next, we have a scheduler. Scheduler's responsibility is to schedule a pod on a worker node. So let's say a request comes to create a pod of 500 MB resource it wants. So it will make sure that, okay, on worker node A, this resource is present and I'll schedule a pod on it. Next, controller manager. So the responsibility of this component is that at all the time cluster is running into a desired state. Desired state means if 3 replicas I have specified, all 3 replicas are running. And the next is cloud controller manager. So as I mentioned that this component is present in case of a managed Kubernetes because our cluster needs to connect with other services of a cloud and it communicates to those services. On a worker node, we have kubelet, kube proxy, and CRI. Kubelet is the one that takes a request to the API server and it is responsible for the communication, the kubelet. And kube proxy is for network communication, like it will be responsible for the pods communications and how that communication is set up. CRI, container runtime, it is responsible to spin up a pod for us. So how EKS is different from Kubernetes? In our traditional or on-prem Kubernetes, the control plane and upgrades, auto scaling, we have to manage it. These are the self-managed. Whereas in AWS EKS, these are managed by the cloud providers. For security integration, we have RBAC, OpenID Connect, secret management that we are going to integrate in our cluster. And we have to take care about the permissions, access control, and everything. In EKS, we can leverage the IAM, Identity and Access Management, that provides IRSA, which is IAM role for service account, and OpenID Connect. Availability, so we have to design our infrastructure and make sure that this is highly available in case of an on-premises Kubernetes. In cloud, Generally, it is by default highly available, but yes, we have an option for multi-AZ and multi-region as well. Customization. So as on traditional Kubernetes, we are managing everything. We are integrating, we are deploying, we are installing. So the control is under our hand. On EKS, as the cloud is also responsible, the cloud provider is responsible to take care of some components. So this control is limited. So why cloud security matters? We are shifting or we are migrating our most of the workload on the Kubernetes cluster, generally the managed one. So we have to take care of what are our responsibility and how our cluster or our applications are secure. So as this is a shared responsibility model, security of the cloud means the on-prem data centers, servers, that is a responsibility of a cloud provider. Whereas if I talk about the permissions part, access control, our infrastructure, that we have to take care of. So that is our responsibilities. Next, we have authentication and authorization. In EKS, or in a general term, first of all, authentication means who you are, who that user is. And authorization is, do you have a permission to access my application or to access my resources in my cluster? So in authentication, for authentication in EKS, we have IAM, Identity and Access Management, and OpenID Connect, both the functionality available. For IAM, specifically, we have IRSA v1 and v2, or PODS identity. Here we have a authentication modes like config map. So in config map, we create a AWS auth config map and we map our identities to the Kubernetes users and group. Then second, we have an API, which is a recommended one. A config map is kind of a traditional method, or earlier we used to do. Now we have a API method. Whereas we have to create a access entries to create or to give permissions. Third, we have API and config map. So we can choose that I would like to use both the functionality and I'll combine these two mechanisms to authenticate my cluster or to authenticate the users in my cluster. Second, we have an authorization. So for authorization, we have an RBAC, role-based access control, which is part of a Kubernetes only. And here we create role and we attach it to a user and that we call it a role binding. Then we create a cluster role and cluster role binding. The difference between these two is roles are namespaces confined that will be applicable only to that namespace. Whereas cluster roles are applicable to the entire cluster. So that's how we define and provide the granular access, like on my pod or present in ABC namespaces, the user can only send a GET request or they can only read list my pods. So that's how we can provide the permissions using an RBAC. That's it for today. Thank you so much. Now I would like to talk about our project OWASP EKS Code. So this is a hands-on masterclass that we have created to learn more about the AWS EKS, and you can refer to this open source documentation available at ekscode.kubernetesvillage.com to have more information about it. That's it. Stay tuned for our next videos on EKS top 10 best practices and follow our channel, PeachyCloudSecurity. Thank you.